children. Today, in the science class, we will be continuing the chapter Force and Pressure. In the previous classes, we have learned about force, effects of force, types of forces, pressure, and pressure exerted by liquids. In today's session, we will be studying pressure exerted by gases. Do you know why the packet of chips inflates in an aeroplane? Why astronauts wear a spacesuit? These questions are very interesting, and the answer to these questions I will be giving you by the end of this session. Let us study pressure exerted by gases. Gases exert pressure in all directions. We see many practical examples of pressure due to air in our daily life. For example, the tube of the tire blows up when air is filled in it. Similarly, a football or a basketball blows up to its proper shape when its bladder is filled with air. A balloon grows in size when we blow air in it. In the above examples, the molecules of the gases keeps on colliding among themselves as well as with the walls of the container, due to which the molecules exert force and hence exert outward pressure on the walls of the container, as a result of which the balloon, ball, or the tire inflates. Now let us learn about atmospheric pressure. To understand atmospheric pressure, let us recall what atmosphere is. We all have learned in our previous class that the thick layer of air surrounding our Earth is called the atmosphere, and the pressure exerted by this atmosphere on the objects is called the atmospheric pressure. Hence, atmospheric pressure can be defined as the force exerted per unit area on a surface by the weight of the atmosphere above that surface. Now, we can conclude that atmospheric pressure is due to the weight of the air column above the object, and its value is approximately equal to 10 to the power 5 Pascal at sea level. Now here is a simple activity to demonstrate atmospheric pressure. For this, we require a tin can, cork, Bunsen burner, water, and matchsticks. We first take an empty tin can and put some water in it. The air pressure inside and outside the can is same. We heat the tin can with the help of Bunsen burner to boil the water till the steam is formed. The steam expels all the air from inside the can. We then fit a tight cork on the mouth of the tin can and stop heating. At the end, we pour some cold water on the hot tin can. What do we observe? We observe that on pouring cold water on the hot tin can, the can gets deformed. We conclude that the steam inside the can balances the atmospheric pressure outside the can. On pouring the cold water on the hot tin can, the steam inside it gets condensed to water and pressure inside the can gets lowered. The large atmospheric pressure outside the tin can crushes it inwards. I hope the experiment is clear from the picture which is given along with it. Now, to tell you an interesting fact. Do you know each centimeter square of a body experiences a force equal to a mass of 1 kg due to atmospheric pressure? If total pressure on the whole body is calculated, it will be large enough to grind us to a paste. But an equal and opposite pressure due to flow of blood and other fluids in our body negates this effect to keep us comfortable. Now let us talk about the factors affecting the atmospheric pressure. Altitude is one major factor which affects the atmospheric pressure. The atmospheric pressure is the maximum on the surface of the earth. When we go to high altitudes, say a high mountain, then the atmospheric pressure decreases. It decreases because the density of air molecule decreases and the height of the air molecule column also decreases. Therefore, the weight of the air column above us decreases and hence it leads to the decrease in the atmospheric pressure. We all might have heard and have even read that the mountaineers they suffer nose bleeding at high altitudes. It is because at high altitudes the atmospheric pressure is much lesser than our blood pressure. Due to this, some of the blood capillaries burst and blood comes out through the nose of the mountaineers. Now, to tell you another interesting fact, as we move out of the atmosphere into the space, our body will balloon up to twice a normal size due to the absence of atmospheric pressure in space. This is the reason why astronauts wear special space suits. The packet of chips gets inflated at higher altitudes because the pressure inside the packet of chips is more than the atmospheric pressure outside. I hope, children, now you've got the answer to the questions which I asked you initially. There's one more interesting example of the effect of altitude on atmospheric pressure. The ears they get blocked while traveling in an aeroplane because the air pressure outside our body changes as altitude changes. This creates a difference in pressure and blockage in ears. Now let's recapitulate what we have learned in this session. We have learned that gases exert pressure on the walls of the container because of continuous collisions of the molecules with the walls of the container. Gases exert pressure in all directions. Atmospheric pressure is defined as the force exerted per unit area on a surface by the weight of atmosphere above that surface. Atmospheric pressure decreases with altitude. Thank you.